Now, all the examples we've seen so far have had more of a linear relationship, but what about if it's a curve shape instead of a line? In this course, we'll keep our description of forms simple, lines versus curves. We won't specify what kind of curves. That'll be in another statistics class or another class you might take in the future, or maybe not. We will dedicate most of our time to scatter plots with a linear form, but on this page, we'll examine a relationship that has a curve form just for contrast. So here's an example of a curved form. What is the relationship between the speed you drive and the amount of gas a car uses? In this study, energizers, what the heck? Engineers measured the amount of fuel, like the Energizer Bunny, I guess, fuel in liters used to drive 100 kilometers. They made these fuel measurements for a car driving at a fixed speed in kilometers per hour. Then they made fuel measurements for different fixed speeds. So looking at that graph, what can we learn about the relationship from the scatter plots? So it looks like the lowest point is down here. So you should drive a little bit over 50, maybe 60 miles an hour to get the best fuel economy, I guess. Using the least fuel to go that speed, using a lot of fuel to go very slow, it looks like. And then you're using more and more fuel as you go higher speeds than 60, as you go from 70 and on to 150. But still, looks like you're using the most fuel when you're going very slow, like less than 10 miles an hour, maybe. But it definitely goes down and then comes up. So you wouldn't say that the direction is positive or negative. It's neither, because it goes at a certain point it goes positive and at a certain point it goes negative. You can't really say one way or the other. Yeah, the data points decrease, then increase. So the direction of the relationship is negative and then becomes positive. In the context of car speed and fuel usage, we see at slow speeds, the car uses a lot of fuel. When the speed is 60 kilometers per hour, the car uses the least amount of fuel. The fuel usage increases gradually for speeds above 60 kilometers per hour. The form is curved, it's not a line. The strength is very strong. All the data seem to fit a smooth curve if you would go back and look. Let's see, wait. Yeah, it's pretty perfect. Like I could draw a curve that hits all, I'm not doing a great job, but I can imagine it's hitting all those lines perfectly. Yeah, and if you're familiar with algebra and higher classes, there are quite a few curves that could fit. There's a parabola, maybe a weird parabola, maybe not. That could possibly be it, but then there are polynomials that are more complicated. It could be something like that. Like if you zoom in on one part of that here, that might look like this curve. I don't know. So that's in another class. We won't look at which of these curved shapes fits the best and finding the model that fits them. That'd be in another statistics class. Anyway, okay, curved. Okay, the strength is very strong. Yeah, the outlier. Okay, the point 10,21 lies above the rest of the data, like it shows. Yeah, we said that these are all fairly kind of close together, but there's one that's way off. It has a super high fuel usage just for, yeah, you're not going very fast. You're going 10 miles an hour. That's not very quick. Let's see. Previously, we learned that 1.5 times the interquartile range rule for identifying outliers in a distribution of a single quantitative variable. But in the scatter plot, you can use this rule to determine if the x value of a point is an outlier with respect to the x values in data. Similarly, you can use this rule to determine if a y value of a point is an outlier with respect to the y values in the data. However, this rule does not help us identify points that deviate from the overall pattern in the data. That's only if it seems like the x value is close to the others, but the y value is not, or the other way around, like the y value is close to the others, but the x value is not. But in this case, it looked like the x value and the y value are not even close to any of the data values. And similarly with the problem on the previous page about the animals and their pregnancy lengths and all that. So is there a method to identify outliers that deviate from the overall pattern in the scatter plot? Well, the answer is yes, but we don't discuss these techniques in this course. That would be in a future statistics course or any future course that you take if you need to analyze data. For now, let's just look at the scatter plots and see if a point deviates from the overall pattern. In other words, we'll see if the point deviates from the direction and form of the data.